That is one more important thing. Huffman tree and code. Huffman trees and code. Tell me, you have enough means interest till left after discussing
Than
so many.
interest, no, it will become
If
too
it is
much
going
for me.
over it, then we can stop today because the
Uh,
things are.
One more algorithm may go over the head because mind is blocked after so much of this thing.
So, should we do Huffman code and tree?
Hmm.
We can do. I have no problem.
Okay, okay, we'll do
See,
it.
as much I am doing, it is another practice of me. So, I have no harm of practicing just before this exam. Okay, maybe I know this thing, but still, practice is something that in every field you must do. Okay, without practicing, it's very much hard to draw the
Yes, you
pictures
cannot
and explain.
demonstrate like this. See, if you have not made this much of practice, this taking like this, it is really hard to come to this level. We don't know like how many circles we have to do. If you have to
Mm,
demonstrate on the spot so many algorithms.
yeah, but why if our medical emergencies was not took place, then probably we could have
We would
did a
have
lot better way. Okay.
one
Okay.
question I had,
Hmm.
only 1 second. So
Okay.
this is apart from the this thing. Okay, one Java question I had, one small doubt. I
Hmm.
thought of it's a very simple one. It is just I was not uh, confirmed to give this answer.
Tell me.
Okay, the question is like this: What is stored in the object obj? Okay, if it
Null. I remember the question.
box obj, so it is
Huh.
null only, na?
It is null.
Not the memory address of an object.
No, no. What is memory address? Okay.
It is nothing like that.
See
Mm.
here, when if suppose you have a class A,
Mm.
B, C. A, B, C is a
Mm.
class. Okay. So if you write A, B, C, R is equal to new A, B, C. Okay.
Mm.
I know this is null. I don't know about their evaluation. Okay.
Mm.
Because in Java they mm, discard 1 point, not 1 point, sorry, half point means one question they
Mm.
differ from me. I don't know which one, maybe this one also. So if
Mm.
you write like this, that means you are this. What is this new? This new will allocate memory.
Operator will allocate some memory.
Memory, okay. And this is the constructor we know. It will do some task.
ABC is a
Okay.
constructor.
So when memory is allocated, means memory is
Huh.
allocated from where? From RAM.
RAM. Mm.
So when memory is allocated, then the amount, then a block, a certain amount of byte will be
Mm.
reserved from the RAM,
Yes.
and the address, suppose this address is 100,
Mm.
address will appear only after the execution of this new. Okay.
Mm.
Now somewhere in the memory, a table will be there, that is symbol
Mm.
table or something like that. Okay.
Mm.
Where this address
Mm.
is kept, means they have to have the knowledge, na? The
Mm.
JVM must have the knowledge that where in the memory this object is situated. Okay.
Mm.
For that purpose, the compiler store the address in a table,
Mm.
and this address gives a name. That name is your R. Okay.
Mm.
And name means what? Suppose your name is Shashikala.
Mm.
Shashikala is a name.
mm,
taken by your parents from a book, from some mythological character, from some anywhere else. Okay,
mm,
that name is attached to your existence, means
mm.
to your figure, to your body. Okay, that
Got it.
person has been referred by this
Identified.
name, identified by
Mm,
this name. So
mm,
that name is called a reference,
mm,
and it is nothing. Okay, it
mm,
is nothing, it's just a name. It do not
mm,
contain any address. Okay,
mm,
now suppose you do not write this line, this
mm,
part, you do not write
mm,
this part, then you will not be executed. It is not even in picture. Then what you have? You have only
mm.
the
Just the-
name.
mm,
Okay, and this name is not attached with anything, any
mm.
address. Then how can it be an address? Because you are
Correct.
not allocating memory. Okay,
Mm,
whenever you are allocating memory, then some amount of bytes will be reserved from RAM. Then the address will appear. And if there is any question about address, then then that will appear after the execution of new. If you do not have new, then there is no question of having an address. No,
mm. Correct.
it's just like suppose you are planning to build your own house,
Mm,
not the flat one. Okay, means
mm,
not the apartment. You are going to build your own house, and you selected that
mm,
when I build my villa, I will give a name to that villa. Na, deta hai, means
mm,
like Santi Villa, or
mm,
say something like that. Okay, in your terms. Okay, say you do not build your house. Okay, you
mm,
do not even buy the uh, means the area or the plot where you
mm,
will build your house, but you just from a market you choose a nameplate, and on the
mm,
nameplate you write the name Shanti Villa.
mm,
Okay, that you can do.
mm.
Is it
But it doesn't refer to anything.
okay? No, what my mm, intent
It
is
does
to tell
not
you
contain anything.
that
Address
you
it will
can
not
do
be
this
here.
thing. You
Mm.
can do this thing, na? Before
But
building the house, you can
I can
take
make
a
the nameplate.
nameplate,
Mm.
but that doesn't mean that the house has already been built. Is
Correct.
it referred to anything? No, it is not referred to anything. That means it is referred to null. It
Mm.
is not referred to any house built yet. Once the house is built, then I can
Mm.
hang this nameplate or attach this nameplate with that house. Then from that point, from that very time, this nameplate or this name referred to that particular building. Okay,
Mm.
so that is called a reference in Java, and that's
So
all.
here it will be null only.
It is null, definitely 100% to me. To me, it is null. Okay.
Okay.
Okay. So Huffman tree. Huffman tree. Acha, is there anything left? Your
No,
question
we can.
was complete.
Yeah, yeah, it
Okay.
was complete. And I just want only one more small doubt,
Hmm.
whether to ask or not, I don't know. Like, I just wanted to know, is there any ambiguity in this kind of question? What I repeat now. Okay, if I'm referring to a type of loop, okay, that
Hmm.
executes for a specific number of time. So, if the options are for loop, while loop, do while loop, and definite loop, is it an ambiguous question or it is a okay question?
Uh, is the question from your CA3?
No, it is not from CA3.
Okay, just
I just
read one more
like that.
time.
It's a means a type of loop that executes the block of statement for specific number of times.
Acha.
Options are for loop, while loop, do while loop, and definite loop. Okay. So is it
Aha.
an ambiguous question?
To me, it's you can take it is an ambiguous question because we do not know. We know while loop, we know for loop, we know do while loop, and we also know that these all three loops can be treated as
Created.
a infinite loop and finite loop. Okay, but we do not know what they are trying to say about definite loop. Okay, because when you club the options with for loop and definite loop, then for loop is a keyworded term, na?
Mm.
For while, do while, these were terms taking from the keywords.
Mm.
Okay, but with that, okay, with the
Mm.
symmetry, definite loop is nothing there. Okay, now if you define a definite loop, then obviously you can say it is opposite of indefinite loop,
Mm.
infinite loop. Okay, so I think they may ask you to choose the definite loop option. But obviously
Okay.
the question is ambiguous because interpretation of the question will
Mm.
differ from person to person. Okay.
And it is based that too based on the options. If
Yeah,
it would have
obviously.
been definite, indefinite, and none of the above, then it could be a definite loop.
Yeah, sure. But whoever give this question, I think
Mm.
their intention is to select the definite loop part,
Definite loop.
obviously. But
Mm.
you see, because you cannot choose the while loop, because if you choose
Mm.
while loop with the same ground, you have to choose do while loop, you have to choose
For and
for
do
loop.
while also at the similar
So
pattern.
there is no reason of giving this for while and do while loop, so we have to go with the definite loop. It's like
Mm.
that. In that way, you can select the option. Okay.
Mhm. Okay, we can continue with the
Okay. So
Huffman's code.
Huffman tree and code is very, 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 very important. Okay, it was there in our network.
Mm.
So Huffman tree is basically this coding is for what purpose? Is
Mm.
for shortening a network.
Mm.
Means what you can say, the data. Okay,
Mm.
suppose a data is there. Suppose you are sending a message from one
Mm.
point to another point through a network.
Mm.
Okay, so
Mm.
in that of your message, you will have many characters, many letters
Repeated.
repeated.
Mm.
Okay,
Mm.
so those all repeated characters is
Mm.
transferred along the network path, and
Mm.
network path is always remains congested, na? So the
Mm.
minimum amount of data,
Mm.
okay, so sending minimum amount of data is always become an advantage. Okay, suppose
Mm.
if the size is your 100
The
kb,
less. Mm.
okay, and if somehow we can reduce it to say 60 kb,
Mm.
so it will be it will put a huge effect in networking, na?
Mm.
In speed. So Huffman
Correct.
coding and Huffman coding is basically that
Mm.
technology, how you can reduce the size of a sending message.
Mm.
Okay, and Huffman tree is the way how you generate that code. What I'm saying, Huffman coding is
Mm.
the technique through which you can
Mm.
reduce the number of bytes to be transferred, and Huffman tree is the technique through which you
Technique.
generate the code.
Mm.
Okay, now
Mm.
suppose you take a say message, say a,
Mm.
I'm not writing this thing, I'm just having like that, a b c a b c b b d b a b a, like that. Okay, so how many characters we have? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. 16 a b c d e, the e a say b, so total 20. Now
Mm.
we have total 20 number of alphabets or characters. You may have different digits, anything na, special
Mm.
characters, you can have anything, but for
Yes.
simplicity we are taking only abcd.
ABCD.
So so this is your total number of total message. This is a complete message
Containing
you
the
have
letter.
to send from one end to another end in a
Mm.
network. Okay. Now see, you have 20 characters here.
Mm.
Now for 20, for one character you will have 8 bits at least na.
Huh.
You will have 8 bit, at least 8 bit. So for
Yes.
20 characters how many bits you have to transfer?
20 into 8.
So how many? 160.
160.
160 bits. Why we are
Mm.
considering bits? Because in network, while you are transferring from one point to another, data are transferred
Mm.
through bit by bit, na?
Bit by bit.
Bit
Mm.
by bit. Okay. So
Mm.
total 160 bits you have to transfer. Okay.
Mm.
Now if we can reduce the bits, number of bits,
Mm.
then obviously the transfer will take place more fast.
Mm.
Okay. So our aim here is to reduce the thing.
The
Now
size of
how can we reduce the number? See here, how many characters are there? What is the set of
individual
characters?
characters. One, two,
A, B,
C,
C, D,
D,
E.
E. 5.
Okay, five characters. Total five
Mm.
characters are there. But
Mm.
what we are taking? We are taking 8 bits to represent a character. Okay.
Mm.
Now with 8 bits, how many characters you can represent?
5.
No.
One
With
character.
8 bits, how many
We can
characters you can represent? The maximum number
256.
of characters?
256.
2 to the power 8 minus 1.
Mm. 255
Okay.
or 256.
So this much amount of characters you can represent with 8 bits.
Mm.
This much. What is this? This is your 2 to the power 8 means what? 2 to the power
256.
7 is 250, 256. 256 characters you can represent with 8 bits.
Mm.
But we have to represent only 5 characters.
Mm.
Only 5 characters. We do not require those number of characters, na?
Mm.
So we do not require those number of bits. Okay.
Mm.
So we can generate our own code. If you take
Mm.
ASCII code, so by
Mm.
taking 8 bits length, we are considering about
Mm.
ASCII code. You
Mm.
can consider Unicode. Then the number of bits
16
will again
characters.
16 bits.
Mm.
Okay. So rather taking those concepts, we are taking our own code. We are generating our own code. Okay,
Mm.
with the minimum number of bits possible, right? So
Mm.
that can be done in two way. That can be done in two way. One is your fixed size code,
Mm.
and another is your variable size code. Means
Mm.
what? In fixed size code, you have to give the code to each of the character with a fixed number of bits.
Mm.
In fixed size coding, you have to give
Mm.
each of the character a code with fixed number of bits.
Mm.
Acha, tell me how much number of bits we require to represent 5 alphabets?
5 alphabets.
What is the number of bits required to represent these 5?
5 will be 5 on means
1, 0,
2.
1. That is 5. So
Ah, 1
maximum
0.
3 bits you
3
have to
bits.
represent.
Yes. Okay.
Maximum 3 bits you have to represent. Okay.
Mm.
See, you can tell me that 5 is 0101.
Mm.
Somebody else can tell me 5 is 00101. So these zeros, our intention
Hard.
is to discard these zeros. We do not
Discard
require
those
that one.
things. Mm.
So by fixed size, a can be represented as, I am just writing in that way, a can be
Mm.
represented as 000. Okay.
Mm.
B can be represented as 001. C
Mm.
can be represented as 00, sorry, 1 0. In the sequential way I am representing, okay. D
Hmm.
can be represented as 0 1 1, and E can be represented as
One, one, one.
1
One,
0 0.
zero,
You can
zero.
represent any number with 3 bits, okay.
Hmm.
You can say that no, I will represent A as 0 1 1, okay, no problem,
Hmm.
because this is your
With
code.
our own code.
This is your own code, okay. And while you are
Hmm.
transferring your code to the
Hmm.
recipient, okay, you
Hmm.
have to transfer this table also,
Hmm.
so that the recipient can match, can understand your
What is the
code, no?
actual message? Hmm.
He or she can decode it,
Hmm.
okay. So there is no harm by taking A as 0 1 0 or 0 1 1, anything you can take,
Hmm.
okay. Is it okay?
Yes, yes, yes. It's
Okay,
okay.
fine. Now if you apply this code, then look how the numbers is, uh, the this amount 160 bits is reduced, okay. So
Hmm.
how many bits are there now? So make a calculation here. 20 characters are there. For each character we have to
Three
use
bits.
3 bits. So total
60.
60 bits. 60 bits you need, okay. Wait, that is not final,
Hmm.
because you have to transfer this field also, no? You have to transfer this table, means A for,
Hmm.
we are taking A for this, B for this, okay.
Hmm.
You have to transfer all
Hmm.
these records too, na?
Hmm.
So to transfer all this record, how many bits you required? You required, see here, you have 5 characters, and all these
Hmm.
5 characters will be represented with their ASCII code, means 8.
Hmm.
So what will be there?
8 5 is 40.
5 into 8
Hmm.
plus, how many are there? 15. 3 into 5 into 3, na?
Hmm.
So total how many bits? So this is your 40 and this is your 15. So 55. 60 plus
Hmm.
55, what is it? 115 bits. Still it is been reduced, na? Initially it was 160 bit with ASCII code. Now with your fixed size code, it is reduced to 115. Now calculate what is the percentage amount of reduction.
Hmm.
Is it okay?
Hmm.
So that is your fixed size coding. Okay.
Hmm.
So if you apply this fixed size coding, then how your message will look like? Initially it will be look like that A will be represented as that 65, na? ASCII value of A is
Hmm.
65, so representing
65.
A will be 65 with
Hmm.
8 bits, okay. But
Hmm.
now you have to represent it as how?
0 0 0.
0 0 0, then
B will
B will be
be
0 0 1,
0 0
0
1.
0 1, then C
Then I
will
can
be
see
0
0 1
0
0.
1 0, like that. Like that, I am not writing the complete string. This will be of length 60 bit,
Fixed length
and the total message
is
packet will be
150.
115 bit, okay. So this is the way how fixed size Huffman code has been created, okay.
Hmm.
Now what is variable size Huffman code? Now we have to see whether this can be reduced still further. Yeah, we can do that, okay, we can do that. Now how? The motto is that, see here, the frequency,
A is uh,
how much one character is repeated.
repeated.
So if you count the frequencies, so let me count the frequencies first, okay. This is your
Hmm.
variable length, okay. So what is the
So
frequency of A?
we are considering for variable length,
Variable
huh?
length, huh? So this is your
Okay.
variable length, okay. So what is the frequency of A? See,
The
1
frequencies
2
one, 2,
3
3, 4, 5, 6, 7,
4
8.
5 6 7 and 8.
mm.
So frequency of A is 8. What is the frequency of B?
B is 1, 2, 3, 4,
1,
5.
2, 3, 4, and 5. Right?
Mm, mm.
So C, what is the frequency of C? Tell me.
Frequency of C 1, 2, 3.
3. What is the frequency of D?
D is 1, 2,
2. What is the frequency of E?
2.
E is 2. Now see which one, which of the character has the most frequency?
8.
A. That means A is appearing most of the time.
Mm,
Now instead of coding A with 3 bits, if we code A with 1 bit or 2 bit, even if
mm,
we go with 2-bit code for A,
mm.
then how many bits we can reduce?
We
8
can
into 1.
reduce
We can
8,
reduce 8 bits.
8 bits could be reduced.
So the aim is here the most frequent appearing
Mm,
letters or characters
mm,
is given the less number of bit code,
mm-hmm.
so that ultimately the total package has been reduced significantly, and
Reduced
it reduced
further.
almost 50%
Mm,
over the total number. Okay,
mm,
so that is the advantage of having variable length Huffman code. Okay, now how can we do that thing? How can we do that thing? Means how can we generate that
mm,
code? To generate that code, we use Huffman tree. How? Let's do it.
mm.
हाँ, पेज खत्म हो गया. अरे बाप रे.
ऐसे भी होगा क्या?
See, these things are so, means I found lots of interesting interest in
Yes,
this
actually, they're
discussing
all
all these
very
things.
nice, interesting, but we should have got this in our.
I'm just copying this thing here.
Mm,
Sorry. This part. Okay. See here, you
mm,
just sort this node. Okay.
mm,
You can consider that this is a node. We are going to construct a tree, na?
mm,
So you need a node, right? Means the vertices, or you can say node of the tree. You identify node.
mm,
Okay.
mm,
So these are the nodes of the tree. Okay.
mm.
The characters along with their frequencies. Okay. Now sort
Frequency.
this node.
Mm-hmm.
If you sort this node, what we will get?
2, 2, 3, 5, 8.
First we write E.
Mm,
E is your 2.
mm.
Then we have D.
D2,
D is again 2,
C3,
na?
mm,
Then we have C.
C,
C what? C is with 3.
3.
C is equal to
B is
3.
5.
And B is 5. I am writing all these things using mouse. I am not using the tab today. I was
Okay.
initially I was planning to take the tab, but the tab has been occupied by other person.
But
Okay,
you
so
wonderfully use this note means paintbrush software. This could be used
yeah,
in this
thank
way
you,
also.
thank you.
I came to know now after seeing your videos only.
Okay, see, this is
After sorting.
this is after sorting. No, this algorithm is going to come, I think.
Mm-hmm.
अच्छा, तो you have sorted all the
Mm,
nodes na?
mm,
So you have to take the smallest nodes and club
mm,
them.
mm-hmm.
How? So what are the smallest node?
DID.
Obviously the first one will
DID.
be the smallest node. Okay.
Mm,
So make a node
mm,
and club these two node. What you will put inside it? You will put the summation of the frequency, that is 4.
mm,
Okay. Now during the process you will not consider this node anymore. Okay.
mm,
You have to consider this node.
mm-hmm.
This is as a node. So this node along with these three nodes, okay, you
Three
have to
nodes.
consider.
Mm,
Now again take the next two smallest node,
mm,
that is your 4 and this
and
one. Na?
three.
So you
Mm,
club this node along with this node and add the thing. 4 plus 3 means 7, right?
mm,
Okay, now you are not going to take this node and this node. Now you have to take this node, consider, right? So what are the two smallest
okay.
node?
Now seven means five.
Yeah, 5. Suppose, see, a is your 6. Okay,
Mm,
so what are the two smallest node? 5 and 6. Then you have to club these two, na?
mm.
Okay, I am just giving you an exception of this.
Got it. I got it.
If these are the two shortest node, then you have to club this.
Club this.
Okay,
It is comparing to the other one, right?
yeah,
Comparing to the clubbed one.
yeah. So now the smallest node is 7 and 5. So you have to club these two. Okay, so you are clubbing these two. Then 7
Seven and
plus
five,
5 is
12.
12. So one is remaining, one node is remain there. So do it.
Left out is 8 only.
8.
We'll club with
So
that.
see, this is one way you can check whether you did right or wrong. Okay.
Mm-hmm.
The final is your 20. How many characters are there? There are total 20
20
characters.
characters.
Okay.
Mm.
Okay. Now in this tree, you have to find the left edges. What are the left edges? These are the left edge, na?
Mm.
Left edge. You have to mark them all as 0, 0, 0, 0, 0. Okay.
Mm.
If you had any other left edge, then you have to mark that left edge as 0. And all the
Mm.
right edges you have to mark as 1. Okay.
Mm.
Now you are going to get the code. So what will be the code? You can easily identify now. So E will be coded as 0, 0, 0, 0, 0, 0, 0, 0. D will be coded as
1.
0, 0, 0, 1,
Oh, from
0,
bottom.
0, 0, 1. 7 will be coded as 7 is C. C will be coded as 0, 0, 1, 0, 0, 1. B will be coded as 0, 1. A will be coded as what? Just 1. Right.
Mm.
Now let's calculate how many total number of bits it will occupy. Okay. I have to go now. So I am making it fast. So E was 2, na?
Uh,
E was 2 means here it is 4, na? Number of
uh,
bit is 4 multiplied by 2. Here D is your again 2. So number of bit is 4. It is 2. It is number of bit is 3. It is C is coming for 3 times.
mm.
B number of bits. C, the maximum appearing bit means maximum appearing characters are
Is
getting less
5.
number of bit, na?
Uh,
2 number of bits, and this is your 8 and it is 1. So what is the value? The total sum. See, this is 8 plus 8, 16. 16 plus 9 what? 16 plus 9, 25.
25,
25 plus 10,
35,
35. 35 plus 8,
30, 35 plus 8,
3.
43.
See, only 43. Initially, what was that? After,
115.
no, 60, 60. After applying fixed size length, we are
Ah,
having that 60. No?
okay. Before means without the table and
Uh,
other things.
Now here it is your 43. And what are the table amount? Table amount will be, this is 5. So 40 will
40.
be there, plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14. So total what is
It
the
is
amount?
80, means
So here it is 54.
97. 97.
97. See, with
97 bit.
fixed size it was 115 bits. Here
Mm,
it is 97 bits only. You
mm,
see the significant reduction in size.
mm,
This is your Huffman coding, and Huffman coding we are achieving it from Huffman tree. Huffman tree. Okay.
mhm.
Tell me. Okay.
Yeah.
So today we stop here. I have to go now. Okay.
Yes, yes.
And so maybe if we can manage, we can sit tomorrow also for the other parts.
Tomorrow I'll just see how it is going to work out for me.
Okay, no problem. You will tell me. Okay, if you
I'll
have
tell
any
you by
time.
something means by afternoon or evening by 5, 5:30 like that at least
Okay,
I'll let
okay, no problem, no problem.